Hello, my name is John Kelly, and this is the Weber Auto YouTube channel. Today I have an exciting transmission to show you. It is a dual clutch automatic transmission. This transmission has been donated to us from Ford. Ford calls this transmission the DPS6. It's a 6-speed transmission that comes in a Ford Focus. The unique thing about this transmission is that it is a fully automated manual transmission. So to the driver of the vehicle, they still have a gear selector that looks just like a gear selector from an automatic transmission. However, the transmission is actually a manual transmission, and it's called a dual clutch, dry dual clutch design automatic transmission. So it's a manual transmission, but it's automatically shifted. So I want to show you some of the parts and show you the power flow through this thing, and talk about some of the issues disassembling and reassembling this transmission. So as the name implies, dual clutch, that means that there are two clutches, dual clutches. Now this is not the same as twin clutches. Race cars use twin clutches or even more so on their input shaft they have multiple clutch discs on one input shaft. That's not what we're talking about here. A dual clutch transmission has this clutch pack that's behind me right here, and this clutch pack actually has two clutches inside of it, and it has two pressure plates inside of it. Because of that, it also has, if we look right here, two release bearings, an upper one and a lower one, and two release bearing forks that are computer controlled with these two electric motors here. These are three-phase brushless synchronous AC motors that apply and release the twin release bearings. Okay, so let's take a look at the input shaft of this automatically shifted manual transmission, dual clutch automatic transmission. By the way, this transmission is made by Getrag. Getrag is known for some awesome other powertrain components, and you will see that in the bolts that separate the case halves, it's the inverted Torx bolts, just like other Getrag transmissions, both automatic and manual. But here on the input shaft, a manual transmission normally will just have an input shaft, and on the end of that input shaft you will have a set of splines, just like these, that connect to and spline to a clutch disc. But I want you to see here on the top of this input shaft right here that we actually have a center input shaft and an outer input shaft. These two input shafts have their own clutch disc that they spline to inside of that clutch housing I just showed you, and this inner shaft here ends up connecting to all of the odd numbered gears. So it's a 6-speed, so that's gears 1, 3, and 5. And then of course this one is the even gears, 2, 4, and 6. And then fourth, also the synchronizer and clutch sleeve assembly provides reverse. So reverse is obtained from this outer input shaft. But let's take a look at the input shaft. Let's take it apart here for a moment and take a look at the clutch pieces that go with it. So let me get positioned here. So this clutch housing, it's very heavy, and as I said, it has two clutch discs inside of it, two pressure plates. So if we take this input shaft here and we separate it into the two shafts for the two clutches, once again, here's our odd clutch, or here's our shaft that can, sends power to our odd gears, 1, 3, and 5. And I want you to notice that I have taken yellow gear marking compound and marked these teeth for the odd gears. And then here in the background, we've got our two counter shafts with our with our gears on it, and the gears that are painted with the yellow gear marking compound, gears 1, 3, and 5, are controlled by this input shaft right here. This other input shaft, the tube input shaft that's hollow right down the middle, is the even gears, and of course it's not painted, so all the gears that are over there on these two shafts that are not painted are controlled by this other input shaft. So here on the clutch assembly, which by the way, you need a very special tool set to even disassemble this transmission. There's a set of tools just to pull this clutch assembly out of the bell housing of this transmission without damaging it. And then there's another set of tools to reset the clutch to where you can reinstall it. And then there's two other sets of tools just for the rest of the transmission. So there are 4 sets of special tools in big red boxes from Rotunda Tools to be able to work on this transaxle. 2 of them just for the clutch and 2 others for the rest of the transmission. And then there's a box with a holding fixture in that I'll show you for disassembling and reassembling the transaxle. So we've got this odd numbered input shaft right here, and on the clutch housing itself on the front we have the clutch disc that is splined to the odd numbered input shaft here. So there's a little hub that comes out. It's held in with a snap ring, which by the way, no snap rings on this transaxle are reusable. You're supposed to throw them away and replace them. But this hub will spline right to this input shaft, and with it on the input shaft there, it will spline to this clutch disc. And notice the clutch disc is free to rotate inside of this housing. So that's for the odd numbered gears. And then if we turn this clutch housing over, here on the back you can see the 2 different sets of pressure plate release springs, except in this case it's just the opposite of a regular pressure plate. These pressure plates actually they're spring loaded to release the clutch rather than apply the clutch like on a traditional manual transmission. So there's a second clutch disc down inside here that our second input shaft splines to, so it goes right in there, and notice it free spins also. So that tells us that these pressure plates with the dual release bearings there that are computer controlled, when they press on these 2 sets of springs, there's an inner set of springs here and outer set of springs here, when they push on those, it applies the clutch, whichever clutch is it's connected to. I assume these inner springs for the inner pressure plate connect to this rear clutch disc, and this outer set transfers through to the front clutch disc. So let me lay this thing down and we'll just put the whole thing together right here. So we'll take our hollow input tube for our even numbered gears, and it'll sit in the rear or the back clutch disc, and then our center input shaft for the odd numbered gears will go right down the middle of the other input shaft and spline through this little hub on the other side to the front clutch disc. So a dual clutch transmission is one that has two clutches, two transmission input shafts, and then each shaft drives only certain gears. And the big advantage of this is that you can pre-select the next gear you're going to go into. So in this transmission, we actually shift into two gears at once. Now you cannot do that on a regular manual transmission, shift into two gears at once. It'll just bind the transmission up, lock it solid. But on this one, since there's two different input shafts, when we are in first gear, second gear is also engaged with the synchronizer sleeve, but there's no power to it. So first gear would be accomplished by turning this input shaft for the odd gears, and then all we have to do to shift into second gear is apply the clutch to start turning this other shaft right here, the tube input shaft. The gear selection had already taken place, and so what that does is it speeds up the shifts. It makes this manual transmission feel like an automatic transmission. The clutch apply rate of how quickly the clutch discs are applied, how much slipping, how quickly it applies, is computer controlled, and so they can make this dry clutch, so there's no lubrication or anything in here, it's just a dry clutch like any other manual transmission, feel like it has a torque converter as far as a smooth apply and release. Okay, well, what I want to do now is take these two input shafts and build them up in the transmission case, and then show you how the whole thing is shifted with all of these unique little gears here. Notice we've got 4 gears coming across right here. Those gears are controlled by the transmission control module that bolts right to the transaxle. Notice on the back of the transmission control module, it has little gears sticking out also. And the transmission control module, the TCM, through these gears, drives these gears, which drive these, which I'll show you here in a little bit, drive some other gears that actually move the shift forks on this transmission. So we've got some very interesting pieces and a very interesting configuration as far as a transmission is concerned. So now I'm going to get these two shafts, and we'll put them in the input side of the automatic transmission here and show you how all the gears are selected. Okay, this big fixture right here is one of the special service tools required for Ford dealerships, and this is an assembly table to put this transmission together, this transaxle. Remember, a transaxle has the final drive, the equivalent of a ring and pinion gear set, and the transmission all in one housing. So even if I call this a transmission, it is a transaxle. I'll try to keep the terminology straight. So what we do is we put all of the different gear shafts together on this thing, along with the shift forks, and mount it all together here so that we can set the transmission case down on top of it for reassembly, because it's very difficult to get all of these gears aligned on 3 different shafts, and they're very heavy also, and get the case all aligned. And so without a table like this, you'd really be in trouble. So we're going to take our hollow input shaft, and it's going to go right here for the assembly, and I'll be able to come in from underneath the table and just spin it with my hand. It has a bearing that goes in there, and then notice our input shaft, The solid input shaft has 2 needle bearings. The shaft surface itself, both on the hollow shaft and this one, are the bearing races. And so if there's any bearing failure at all, both these shafts have to be replaced. And then of course there's a bearing on the end here. And so I'm going to put this shaft down inside of the other one. So we have our dual shafts set up. So right now I'm going to spin the input shaft for the odd gears, the one that's painted, and that would be like the front clutch in that clutch housing over there being the one engaged. And then the even geared one, I'll spin it now. Notice I can spin it without spinning the odd numbered one. So that would be like the rear clutch in that clutch housing spinning the input shaft. So 2 separate input shafts. They can even spin opposite directions. I don't think they do in real action driving down the vehicle or driving down the road, but the idea here that's important to realize for a dual clutch transmission is we have 2 separate input shafts. Okay, now we need to install these counter shafts. So I've got a counter shaft here with 1st and 5th gear on it. And then we've got 6th gear right here, and I believe this drives the reverse, and then this one is second gear, yes. So 6th and 2nd, and then on the other shaft we will have 4th. So this one is going to sit up in here. Like that. And then we've got one more shaft right over here. And this one has 3rd, 4th. This one has 3rd, 4th, and reverse on it. So let me set it up inside of here. Now, normally you wouldn't set all these up here individually like this. There's another steel plate holding fixture to get these installed all as one assembly, but there. All right. So I've got them installed on this holding fixture table, and once again the gears that are painted yellow are the odd gears. And so let's take a look. Let's identify these gears one more time. So we've got 1st, 3rd, and 5th gears right here, and they are driven, and I'm going to rotate the center input shaft. They are driven off of the front clutch in that clutch housing. And then we've got 2nd gear down here, 4th gear over here, 6th gear over here, and then reverse over here. And I'm going to drive those with the other input shaft, which is driven off of the rear clutch in that clutch housing. Okay, notice we have 4 sets of synchronizer sleeves, 4 sets of synchronizers. If your synchronizers are worn out and your end play between the synchronizer and the gear is too thin, both of these shafts are not repairable. You have to replace the entire shaft assembly rather than taking the thing apart and replacing individual gears or synchronizers. Okay, now what's incredible on this transmission, besides just the neat design of the dual clutches, is how it is shifted, how the shifting is controlled by the computer, and how the electric motors through gears make the gear shifts occur. So I'm going to set that up next. Okay, we've got 4 shift forks to install on this transaxle. This particular one I have labeled for 6th gear and 2nd gear. 6th gear is right here. 2nd gear is this big one down to the bottom. And so this will come in right here and line up, and it goes clear across the front, clear to this other side, and then the next shift fork to install is the one that controls 3rd gear. So 3rd gear is this painted one back here. If we bring this synchronizer sleeve down with this shift fork, that'll give us 3rd gear. So this one comes in over here into the 3rd gear sleeve and lines up over here just like that. And then we've got 2 different shift fork shift shafts that we will put in and line up. We'll put one in at a time here, and there's holes in the table to hold that together. This slides in here, lines up, and then we've got another shift shaft that comes down into the table. So we've got a shift fork that's controlled by moving this side up and down, and the whole thing goes up and down for 6th and 2nd. And then this shift fork that controls 3rd is actually controlled from this side by lifting up or down on this side. So 6th, 2nd, and 3rd are controlled here. Then I've got another shift fork. This one is labeled for 1st gear and 5th gear. Well, 1st gear is right here, 5th gear is right there, and so this comes in just like that. There's a hole in the table to hold that in place, and we'll put that down in place. And then on the other side, we've got another shift fork that's labeled for 4th gear and reverse. So we'll slide that into this shift sleeve and set it down. Get it lined up. Okay, we have all 4 shift forks installed, and I told you the exciting, unique thing about this, or one of the exciting, unique things about this design of Transaxle is how it is shifted. Now remember, we've got this transmission control module that shifts the transmission, and it also controls the apply and release of both clutch discs. So on the back of this transmission control module, we've got these 2 gears. Those 2 gears, as I showed you earlier, drive these 2 gears, which drive these 2 gears, which drive 2 more gears. And I'm going to get those gears out right here. So we've got 2 other sets of gears here. And let me zoom in so you can see what these things do. It's pretty neat. These gears, as driven by those little gears, are connected to this bottom plate that has these grooves ground in it. So notice as I rotate this groove, as I rotate this groove, the groove goes up to a kind of a midpoint, and then it goes up high, and then it goes down low and back down. So let me rotate that again. Goes high, midpoint, low. And those grooves connect to these two pieces on the shift forks for the third shift fork and the 1-5 shift fork. So as these grooves rotate around, it's going to lift these shift forks when it reaches this bump here, and it's going to pull down the shift forks when it reaches this little ramp going down. And so we can downshift when it gets right there. It's kind of a neutral position right there, and then it'll or not downshift, but move it down. Then it'll move it up when we get to this point. And so these are sitting in here like this on this side, and we've got another one here on the other side, and it's going to do the exact same thing and sit right here on this other side. So let me get those lined up and sitting there. All right, now this is the this is the entire transmission assembly right here without the final drive, as far as the gears and the shift forks are concerned. So we've got our input shafts. We've got our odd input shaft right here for the odd gears. We've got our even input shaft right here for the even gears. And then we have computer controlled through gears on the back of the transmission control module and other gears through a massive gear reduction and lots of torque to be able to move the shift forks up and down. And so I want to show you an example of that, but the problem is without having this in the transmission case with the upper case holding everything down and aligned, these shafts wobble all over the place here on this table. So it doesn't make for a very good demonstration, but I'll try my best to show you how this works. So let's start with, well, let's go through the gears. Let's start with first gear. So if we turn this table around, right here is our first gear. Here's our first gear shift fork. Here's our first gear shift sleeve. To go to first gear, all we are going to have to do is move this shift sleeve up. Now to move that up, we're going to take this geared ramp and we're going to rotate it. And if you look right here, it starts to come up the ramp. It's trying to push up on the shift sleeve. I'm just going to help it with my thumb here. And click. It's in first gear. We've rolled up the ramp that moved the shift fork up, and we've engaged the synchronizer hub through the sleeve to first gear. And then down here on the bottom of these two gear assemblies, we have two gears, these two gears right here, that drive the final drive with the differential in it. So this final drive gear sits up in here and is driven by either this shaft or this shaft. Now they're both splined together to it, but only one of them will send power to it at a time. So this is our final drive. It just has a regular open differential inside of it. And we will just set this off to the side for now, since I'm not able to include that in this demonstration. There's no place to hold it here. But so we're in first gear. We have power coming from our center input shaft, sending power to this final drive gear, the equivalent of the pinion gear on a ring and pinion gear set. Notice the other one is not rotating. Now, while we are in first gear, the TCM is predicting that we are going to want to go to second gear. So it's going to pre-position the shift fork for second gear. So if we look right here on our shift fork on this same housing, on this same counter gear, we've got the 6th gear and 2nd gear synchronizer sleeve and hub, and 6th gear is here, 2nd gear is here. So what we're going to do is move this shift fork down so that we can engage the synchronizer hub to this gear right here. It also has the reverse idler gear. So this is reverse idler, this is second. They're both controlled by, they're both splined together. So by moving the shift sleeve down, we'll go into second gear. But that shift fork is not controlled by this gear. It's controlled clear over here by this other gear, and we are going to want to bring that shift fork down in order to go into second gear. Now keep in mind, we're still in first gear, but while we're in first, we're going to rotate this sleeve, or not sleeve, we're going to rotate this shift fork to the downshifted position. So let me get it pre-positioned correctly here. So we're ready to bring it down. Obviously these have to be clocked correctly when we put the transmission together. And then the TCM does an initialization procedure to figure out which gear it's in also. And then it can tell what gear it's in by the speed sensors, the input speed sensor versus the output speed sensor. But let's bring this shift fork that stretches all the way through down this ramp. So we've got this ramp going down right here, and we will bring that in and down to the second gear position. So I'm going to rotate that and attempt to bring it down. Like with any synchronization, the gears have to be lined up. There we go. I moved it down with my hand. You can see right here that the ramp has gone down. That pulls this synchronizer sleeve down to second gear. Now notice that the second gear is not painted. So that means the other clutch is the one that applies power to this. So we are in first gear right here on this shaft, and we're turning everything in orange is turned by that center input shaft. We are shifted as far as the synchronizer is concerned into second gear, but there's no power being delivered to second gear because we don't have any, the clutch to the hollow input shaft is not turning. So to go from first gear to second gear, we're in first, we've pre-positioned the synchronizer sleeve into the second gear position. All we have to do to shift from first to second gear now is simply release underneath the table here, so you can't see it, but just imagine we've got these two input shafts at the bottom here. The odd input shaft, the center one, is turning right now from the front clutch disc in the clutch assembly. Now to shift to second gear, all we have to do is release that front clutch disc and apply the rear clutch disc. So now I'm turning the hollow tube input shaft, and that now sends power directly to these gears that are not painted, and now we have power in second gear going to the final drive output here, giving us second gear. Notice things are flopping around, so it's kind of bending out just a little bit, which obviously it would not do in the transmission case. So what I'm trying to tell you is every gear that you will be in, if you're in first, second is also applied. When we go to second, third will be applied. When we go to third, fourth will be applied, and fourth, fifth will be applied, fifth, sixth will be applied. Now the TCM has to guess, has to estimate which way you are upshifting or downshifting, and I imagine it looks at things like accelerator pedal position, how quickly you've stepped on the accelerator pedal. Are you accelerating? Have you let off on the gas pedal? And or if you're decelerating, then we want to pre-position the next shift to be a downshift rather than an upshift. And then if you step on the brake pedal, of course, maybe we want to downshift and skip a gear. I'm not sure if this has gear skipping capabilities, but I would imagine that it does. So we've gone from first gear to second gear just by turning these little shift. Actually, I don't know what the official name of these are, but these little shift gears with these ramps to move the clutches or the shift forks up and down. All right, so we are in second gear, which means we can release first gear. So now we will we'll rotate this gear in the same direction, and that's going to pull down this first gear synchro. Now we've just released first gear up here, and as it continues around, since we're in second gear, the next gear we want to go to is third. Whoops, I'm going the wrong direction. Let's go back up to fifth. We spin this the opposite direction. So there we just released first gear, and now we are going to pull down right here with this ramp, this synchronizer shift fork, and that will pull this synchronizer sleeve down into third gear as we rotate it. So I'll try to get it to come down as I rotate it. Once again, the purpose of a synchronizer is to synchronize the speeds of gears that are turning two different speeds and make them lock themselves together. And so there we go. It went down into third. So we've moved our third gear shift fork down. We've engaged this shift hub through the sleeve to third gear that we've got painted right here. So now, if you recall, we are in second gear, but we've pre-positioned the next gear, third gear, to be ready to upshift. So in second gear, I'm driving the hollow input shaft with the rear clutch disc. To go to third, I just simply release that clutch and start spinning the third, or the center input shaft with the front. And now notice our power is being delivered to this other output drive gear, which is the equivalent of a ring gear on a ring and pinion gear set. So now we are in third gear. We want to upshift into fourth gear. So we had better release our second gear that was still applied over here. So here we are still in second. So now we will have to bring it back up, which it's controlled by this other side here. So we're in second. We need to start heading back towards the sixth gear position. So we're going to head up here So that released second. We are in third, and we are ready to go into fourth. To go into fourth, we need to lift this shift fork up. So that'll have to bring this gear around and lift up on the fourth gear synchronizer. Once again, getting everything lined up, attempting to get it to go up. It's pretty hard to do. Let me try rotating things just a little bit. Come on. Almost. There we go. Okay, so I warned you it would be hard to make this demonstration work, but here we go up into fourth gear. We're in third, which we're driving with the center input shaft. To go to fourth, we just release that front clutch, apply the rear clutch, and now clutch discs, and now we're in fourth. So I'm not moving any shift forks. Right now we're in third. I'm just spinning the center input shaft. Right now we're in fourth because I'm spinning the hollow input shaft. So the shifting on this transmission takes place by changing which input shaft we physically turn. The shift forks pre-position for the next gear. All right, so that's fourth gear. We are ready to go to fifth gear. So fourth is even gear, fifth is a odd gear. So we need to do two things. We need to release third by taking this clutch fork back up, and we need to go to fifth, which is bringing this clutch fork down. So let's see, we are in fourth gear, so the proper order would be to release third gear first. So we're going to have to lift it up, so we will continue rotating this. And so that's, oh no, I'm sorry, that's third is controlled by the other side. So we will lift third back up to its released position. So that's this gear here. We're going to turn it, bring it up the ramp through the shift fork. There we go. Now we're in third. Or now we've released third. We are still in fourth as far as the shift fork is concerned. And now we need to apply fifth, which would bring this one down. So this same motor, the same gear, I mean, just released third, and now it's going to apply fifth by pushing down on the shift. There we go. Shift fork. So the same motor released and applied. So now we're in fourth gear. I'm turning the hollow outer input shaft with the rear clutch disc. Now to shift to fifth gear, all I have to do is apply the other clutch disc. So now we're in fifth gear. Notice we're back to driving this other output shaft or output gear for the final drive. Okay, so that's fifth gear. Now let's go to sixth. To go to sixth, we're in fifth already. We need to release fourth gear. Fourth gear is applied over here, so we need to bring fourth gear down, and we need to bring sixth gear up. Both of those are done right here by turning this motor, or this gear, turning this gear. So we'll start to turn. That pulls down on the fourth gear shift fork. There we go. We just released fourth. That ramp is coming around, and it will lift up now on the sixth gear sleeve, which here on the other side, as we rotate it, once again, easier said than done. There we go. Now we are in 6th gear. We have 5th gear applied, so we're driving the center shaft for 5th gear. To go to 6th gear, we release that front clutch disc in the clutch housing and turn the rear clutch disc, which turns the hollow input shaft. And now we are in 6th gear. And notice in 6th, the only other gear you can go back into is 5th, which is already applied. So to downshift, we just change which input shaft we use. So hopefully you can see the whole thing has just been toggling back and forth, input shaft, the odd shaft, the even shaft, the odd shaft, the even shaft. All right, now let's take this back to its neutral position. And pull this one back down. All right, we are in neutral right now. Notice neither output shaft gear turns with the input shafts turning. And now we want to go to reverse. So this shift fork over here, the 4th reverse shift fork, just simply needs to be pulled down. So we'll rotate this gear down to the 4th, or to the reverse position. Looks like that lifts up. Maybe I didn't have that positioned properly. So we'll rotate, pull this down. Almost. Oh, come on. There we go. So we've now moved the shift fork down to the reverse position, and I believe reverse is driven off of the hollow input shaft. Let me turn it, and we'll see if this gear turns the opposite direction now, and yes it does. So now we are in reverse, driven off of the rear clutch disc in the dual clutch housing. Okay, well, this has been a demonstration of a very cool dual clutch automatic transmission, the Ford DPS6. It's also the Getrag DCT 250 dual clutch automatic transaxle, and this has been a demonstration of all the gears, the input shafts, the clutch discs themselves. And then there's one last thing I want to show you to finish up, and that is, let's take a look at this input housing here. In the input housing, we are going to have, of course, our 2 release bearings. And each release bearing needs its own clutch fork to come in and lift up on it. So we've got 2 different release bearings that can be lifted up and down. And this is bolted here, of course, to the inside of this input housing, or the bell housing. Well, the shift forks that lift up and down on the release bearings are these pieces right here. This piece here. So this is going to come in and lift underneath that lower release bearing and lift it up and down. And what I wanted to show you is how it actually lifts it up and down, because these are computer controlled with these. There's 2 of these electric motors, and so on the end of this electric motor is a little tiny gear. I don't know if you can see that. On the end of this shift fork assembly is another gear. They spline together. And so as this electric motor turns, up inside underneath here, there is a ramp. And that ramp as this motor turns, these wheels are pushed forward and backwards, which lifts and lowers the release bearing. And so I'm going to rotate this, and let's see if it'll, yeah, here we go. Okay, I'm pushing the rollers out. You can see the rollers are coming out here, and it's lifting up on the clutch fork. So that would be applying the clutch disc when it lifts up like that. Now, of course, this housing over here doesn't spin. the rotor inside of the brushless motor here would spin, but it turns when I rotate it here by hand. And then to release the clutch, we're going to turn it the other way. The wheels roll back, the ramp and the fork comes down because those rollers have gone away from the ramp. So that's a very neat way of applying and releasing. And these two clutch fork assemblies, like here, there's two of them. They sit in here. You can see one sits right here on these pads, the other one sits here on these pads. So they're kind of like this. One lifts the big one lifts the small one. And once again, they are computer controlled. So this transaxle has two electric motors built into the transmission control module to move all 4 shift forks to give us 6 forward gears and reverse. And then it has 2 more electric motors to control the release bearings, which in this case are just the opposite. They're actually apply bearings for the clutches, because the clutches are released by default. All right, let's bring the clutch over here just for a moment. The clutch, before you can put it back in the vehicle, and it has to be pressed on, by the way, with a special tool set, there's a reset procedure where all of these springs for the pressure plate have to be pushed down and locked into place. If we push these down far enough, there's a little plate right here that will grab those and hold this in the applied position. And the same with down here. There's little locking tangs that'll lock into place. And so there's a special tool to actually apply both clutch discs. It centers them first, like an alignment dowel that you would use to align a clutch disc with a flywheel on the back of an engine. Well, you have to align the clutch first because it's flopping around in here. You can see it's got up and down movement. So it has to be centered in the housing, and then they lock that disc in the centered position by doing what's called this reset procedure. And then you can install it back in the transmission housing. And once it's installed, then there's a snap ring that goes over this bearing that you put back on that holds it to the input shaft, and then there's this little hub on the outside that comes in, and there's a snap ring that holds it in place into this clutch housing to engage both clutch discs into the clutch housing itself. All right. Problems with this transaxle. I have heard that there have been some problems with the clutch getting contaminated with oil or grease. And I don't know this for a fact. I'm not sure what's going on. I know that when I went down to the Ford dealer here locally to buy some snap rings that were missing in this transmission that was donated to us, I talked to the parts guy, and so here's some snap rings that I bought. The big one that holds the clutch hub in place, and the little one that holds the clutch assembly to the input housing. And there are many other seals and snap rings and bearings that have to be replaced if you take this apart at all and put it back together. A lot of non-reusable parts. But what he told me is that these clutch assemblies have been redesigned. There's a new model, it's back ordered, and so I couldn't even order one if I wanted to, because they are giving them or they're giving customers with vehicles first priority, and of course a training transmission is is not a very high priority. So we'll just wait and see what the new design clutch disc is. When I did take this transmission apart, there were two things that I noticed that I wanted to point out to you. The first thing was there was a huge streak of not oil but grease. It looked like wheel bearing grease or something. It was a thick streak of grease, 2 or 3 inches in, all the way around inside of this bell housing. And then as I was disassembling the transaxle, and I took out this release bearing, as I took these plates off, I noticed that on the sleeve that this release bearing slides back and forth on, there was some heavy blue grease that is there to lubricate this and allow it to slide back and forth easily, and this bolts up inside the bell housing there. Well, that grease looked like, and on the back of this plate sitting right here, like maybe there was too much grease there, I don't know. But it was flung out and into the clutch disc, where it had flung clear out, worked its way all the way out to the outer housing there. And the last thing you want to have happen on a dry clutch is to get it wet, because then it becomes very touchy, grabby. It won't slip like a dry clutch should. As you're applying and releasing the clutch, you want it to be nice and smooth. Any oil or grease that gets in there can be really bad. So as you're assembling these, make sure that you're replacing all the seals that you should, that you're doing everything according to the manual, and then don't overdo it on the grease that goes on the release bearing. I don't know if that's what the problem is. I have no idea, but I just noticed that when I took this particular transaxle apart, that heavy thick grease looked just like the grease that was out here, and it had fling marks, outward marks all the way around with that blue grease, and so that was a problem. Now the other thing I noticed is when you take this transaxle apart, when you take all of these housings, or not housings, these gear shafts out, if you pull too far on the shift sleeves, let me zoom in here, and there's I don't know if you can see it, there's a little chrome colored ball bearing right there in the middle of that light colored plastic detent there. When I took this transmission apart, I lifted up on some of these sleeves as I was lifting them out, and two of those little check balls, or two of those little balls, fell out. Now I know they hadn't fallen out while the transmission was assembled, because they would have been ground up and there would have been signs of damage in the transaxle, but I didn't see any. And I'm pretty sure I can just work those back in, but just be warned, be aware that if you take one of these apart and lift on these sleeves as you lift these heavy parts in and out, you might lift it higher than it was ever intended to go, and those little check balls might fall out. The other thing of note when putting this transaxle back together is there's a special procedure to, let me zoom back out here so you can see what I'm doing. There's a special procedure to set up the bearing preload on these side bearings for the differential. There's a shim that goes under one of these side bearing cones, and there's a special tool set up to make sure that there's a proper amount of squeeze or load, preload, on these side bearings. If you don't set that side bearing preload properly, this gear, as it rotates, can also wobble back and forth if the preload is too loose. If the preload is too tight, you may end up burning the bearing up. And this bearing looked a little bit dark when I took it apart initially, and I'm wondering if maybe the preload was a little on the high side. I don't know. I did not measure it when I took it apart, but I will certainly measure it when I go back together. And you always want to do that with lubricated bearings and make sure the preload is correct. There's no service on the open differential pieces. You replace the differential as an assembly. Okay, well, this has been a demonstration of a very cool transmission, the dual clutch, automatically shifted manual transaxle that Ford uses in the 11 through 14 Ford Focus. It's used by other vehicle manufacturers around the world also. Ford's not the only one with a dual clutch transmission. It's in a lot of high performance vehicles because it shifts very quickly and can outperform an automatic transmission, and it's lighter weight. This is a much lighter weight transmission compared to an automatic transmission, and so the lighter weight will help improve fuel economy and emissions. So thanks for watching. Have a good day, and we'll see you next time.